Hello, everybody. Today we're going to discuss lesson 6.1, equivalent fractions. You'll want to have color pencils to help mark the grids for the fraction pieces. All right, and so Joe cut a pan of lasagna into third-size pieces. He kept 1/3 and gave the rest away. Joe will not eat his part all at once. How can he cut his part into smaller, equal-sized pieces? So we know he has 1/3, and we need to know how can he cut his part into smaller, equal-sized pieces. So draw on the model to show how Joe could cut his part of the lasagna into 2 equal parts. And it says we can rename these 2 equal pieces as a fraction of the original pan of lasagna. Well, the original pan was 1/3. So how many rows are in this 1/3? 1, 2, 3, 4, 5, 6, 7, 8. So if I went and cut the 8 rows in half with 4, I would then be doubling the number of pieces in the whole pan. So now, instead of 3 pieces, there would be 6 pieces. So now, how much is each fraction of the pan? That's 1 out of 6, 1 out of 6, so on. So each piece is now 1/6. What fraction of the pan is 2 pieces? 1, 2, out of how many? Out of 6 pieces. And we can rename 1/3 as 2/6. Okay, so now draw on the model to show how Joe could cut his part of the lasagna into 4 equal pieces. 4 equal pieces. Well, this was 2 equal pieces. Is there a way of taking this part and making it into 4 sections? Well, this one has 4 pieces here. If we went and cut it in half 2 and did the same thing down here, that would give us 4 sections. So let's do this. Let's take our 8 pieces and divide by 4. So that would be 8 sections divided by 2. Each part would be 2 rows. They would be divided into two rows each. So we're taking the 8 rows here, dividing by 4 to make rows of 2s. And that should give us 4 equal sections. And it does, right? Row of 2, row of 2, row of 2, row of 2. Okay, so we took our 8 pieces, divided by 4, and we have 2 rows in each piece. All right, so how many pieces would there be? Well, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 total pieces. What fraction of the pan is 1 piece? 1/12. What fraction of the pan is 4 pieces? So what part of this pan is shaded? 1, 2, 3, 4 out of 12 pieces. So I can also name 1/3 as 4/12. So fractions that name the same amount are equivalent fractions. So we can write the equivalent fractions for 1/3 as 1/3, 2/6, 4/12. Right, so let's look at page 238. Compare the models for 1/3 and 2/6. How does the number of parts relate to the sizes of the parts? How does the number of parts relate to the size of the parts. So originally we had 1/3. And then we made it into 2/6. Well, the number of parts, we have twice as many parts. The size of the parts decreased. Originally, this whole piece was my 1/3. Now I have smaller pieces. I have the same amount, but the pieces itself are smaller. So the model for 2/6 has twice as many equal parts, twice as many equal parts as the model for 1/3. Okay, let's see if we make sure we understand this. Originally, it was 1/3 shaded. We now have twice as many equal parts as we had when we had 1/3. Right? We had 3 pieces originally. Now we have 6 pieces. So it's twice as many. Okay, and the parts are half the size of the 1/3 model. Right? Each piece is half of what it originally was. Okay. So 2, describe how the numerators are related and how the denominators are related in 1/3 equals 2/6. All right, so let's start with this. A whole divided into sixths, a whole divided into sixths has 2 times as many parts as a whole divided into thirds. So what does that mean? So that means the numerator and the denominator in 2/6 are each twice the numerator and denominator in 1/3. Okay. So a whole divided into 6 has 2 times as many parts as a whole divided into thirds. We look here, and 6 is 2 times as much as the thirds. So the numerator and the denominator in 2/6 are both twice the numerator and denominator in 1/3. So in other words, I can make an equivalent fraction by multiplying both the numerator and denominator by 2, and I would get 2/6. So if the total parts is twice as many, the number in the numerator is twice as many. So does 1/3 equal 3/9? Yeah, yes, it does. Okay, a fraction with 9 as the denominator has 3 times as many parts or 3 times as many equal parts as a fraction with 3 in the denominator. And yes, a fraction with 9 in the denominator has 3 times as many equal parts as a fraction with 3 in the denominator. So the numerator is also 3 times as much. So we're saying 1/3. The denominator is 3 times as many parts. So we went from third size parts to ninth size parts. So there's 9 pieces in the whole now. And I went from 1/3 to 3/9 so that they're equivalent. All right. Savannah has 2/4 yard of ribbon and Isabel has 3/8 yard of ribbon. How can you determine whether Savannah and Isabel have the same length of ribbon? Now, remember that the equal sign is written as the 2 horizontal lines, the 2 parallel horizontal lines, and not equal to sign, which would be the equal sign with a slash through it. Okay, so the equal sign and not equal to sign, not equal to sign, show whether fractions are equivalent. Tell whether 2/4 and 3/8 are equivalent, right? Equal or not equal to. All right, so the first thing we're going to do is shade the amount of ribbon Savannah has. Okay, Savannah has, well, let's go back and circle this. So Savannah has 2/4 yard. Isabel has 3/8 yard. And we need to tell whether they're equivalent. So Savannah has 2/4. Okay, and Isabel has 3/8. So she was going from fourths. We're comparing fourths and eighths. So to go from fourths, you'd have twice as many parts, twice as many equal parts if you have eighths. So that's why we have 8 pieces, and 4/8 would be here, but it's actually 3/8. She's 3/8. So if we just compare the two models, you see that they're not equivalent space. So they are not equal to each other. So 2/4 does not equal to 3/8. Okay, we can also verify this by saying 2/4 times something equals 3/8. Well, we know eighths are 2 times as many. Whatever I do to the denominator, I also will do to the numerator. So if the denominator is twice as many, the numerator has to be twice as many. 4 times 2 is 8, so that's great. Does 2 times 2 equal 4? 2 times 2 equal 3? No, it doesn't. 2 times 2 is 4, so it does not equal. Okay. Right, 239. So use the model to write an equivalent fraction. So here we have 1/5. And we need to do an equivalent fraction. Well, I noticed that each of the sections has 6 rows. So if I divided that in half, each row in half, I would double my number of pieces. So if I draw a line through there, let me use something a little darker. Okay, so we're drawing our line through there. Now we have how many pieces? We have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 pieces. Now we have 10 equal parts. How many do we have that are shaded? We now have 2 parts shaded. So what would that look like just as a number sentence? It would have been 1/5 times what equals 2/10. Well, we doubled the number of pieces. So we're multiplying the numerator and denominator by 2 over 2. All right, 2/3. And we have to come up with an equivalent fraction. Well, I can also divide things vertically. Okay, I don't always have to go horizontally. So let's see how many sections there are total. How many columns are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So that's an easy number to split in half, right? It would be 6. If I take 12 and divide by 2, I'd get 6 parts. 1, 2, 3, 4, 5. Sorry. 1, 2, 3, 4, 5. Okay. So if I divide it that way, I no longer have thirds. I have sixths. 1, 2, 3, 4, 5, 6. So sixths, and how many parts are shaded? I now have 1, 2, 3, 4 parts shaded. Okay. Math-wise, that would be 2/3. And I'm saying let's double the number of parts. 2 times 2 is 4. 3 times 2 is 6. All right, tell whether each of these fractions are equivalent. Right, yes or no. 1/6 equals 2/12. How do I go from 6 to 12 parts? You double them, right? Multiply by 2. So whatever I do to the denominator, the numerator will also have the same thing happen to it. So I double the denominator, so double the numerator. 2 times 1 is 2, so yes, it's equal. Number 4, 2/5 times something, does it equal 6/10? Well, if I multiply 5 by 2, that would double the size of the denominator, or the number of equal parts. And I also have to multiply the numerator by 2. Is 2 times 2 6? Is it not? So 2/5 is not equal to 6/10. Is 4/12 and 1/3 equivalent? Can I multiply 1/3 by something to get 12? Yes, 4, right? So I'd have to multiply both the numerator and denominator by 4. 4 times 4 is 4. 3 times 4 is 12. So this is correct. It does equal 2/4 and 5/8. What can I multiply fourths by to get eighths? 2. Okay, so I'm doubling the number of parts. 4 times 2 is 8, and 2 times 2 is 4. Oh, 4 does not equal 5. 5/6 times something equals 10/12. Well, if I multiply the sixths by 2, I'd have 12 equal parts. If I multiply the numerator by 5, I'd also get 10 parts. So this is true. Because 5 times 2 is 10, and 6 times 2 is 12. 1/2 and 5/10. Can I multiply 1/2 by something to get tenths? 5. Is 5 times 1 5? Yes, it is. So that's equal. All right, number 9. Manny used 8/10 size parts to model 8/10. Anna used fewer parts to model an equivalent fraction. How does the size of a part in Anna's model compare to the size of a 10th size part? What size part did Anna use? So what we're saying is went from 8/10 to something that has fewer parts. Well, let's take half of the 10 equal parts and let's just make them 5 parts. So 5 times what is 10? 2. 2 times what is 8? 4. So 4/5. So a part in Anna's model is larger. She has less equal parts. And they use the same amount. They use an equivalent amount. They just how they represented it. The size of the pieces in Anna's model is going to be larger than Manny's because she used a 5th size part. He used parts that are twice as many, or 10 parts. All right, number 10. How many 8th size parts do you need to model 3/4? Well, we can draw a picture of that just to prove it. But let's start with 3/4. So 1, 2. All right, so that's roughly fourths. And let's shade in 3/4. Okay. And now how can we make, it says 8th size parts. So how can I go from 4 in my model to 8? Well, I could just cut it in half. So I'd have twice as many pieces. All right, so I went from 3 pieces to now having 6 pieces. Okay. So how many 8th size parts do you need to model? We would need 6 of those. You need 2 times as many eighths to model the same as 1/4, same amount as 1/4. You need to multiply 3/4 by 2 halves to get 6/8. So we need 2 times as many eighths to model the same amount as 1/4 size part. If we have 2/8, it would be equal to 1/4. So in order to model 3/4, an equivalent fraction, we'd have to multiply the numerator and denominator by 2 halves, and that would give us 6/8. All right. 240. Ben brought 2 pizzas to a party. He says that since 1/4 of each pizza is left, the same amount of each pizza is left. What is his error? Well, remember when we compare fractions, we need to compare fractional parts of the same size things. This circle pizza is not the same as this rectangular pizza. So the areas are different. So the size of the parts are not the same. All right, so since the pizzas are not the same size, 1/4 of one pizza is not equivalent to 1/4 of the other pizza. So now we need to draw 2 models of pizzas with a different number of equal pieces, and then use shading to show 1/4 of each pizza. Okay, so we're going to have 2 circles as closely as we can get. Okay, and the first one, I'm going to have 4 equal sections, and I'm going to shade 1/4. Okay, so that model is 1/4. And I need something that's equal to it. So what can I multiply the 4 parts by to get something that's equivalent? Well, we know that if we multiply, basically if we double the numerator and denominator, we'd have an equivalent fraction. So if we go from 4 parts to 8 parts, we would be something that's equivalent. So let's go with our 8 parts. Okay, and how many parts would be shaded? 1 times 2 is 2. So it's going to take 2/8 to equal 1/4. Okay, so that's what it should have looked like. All right, now number 12. For these numbers, 12a through 12d, tell whether the fractions are equivalent by selecting the correct symbol. All right, so is 3/15 equal to 1/6? Well, let's see. Let's go with 1/6 times something to equal 3/15. Well, this one I'm going to say no right away, because what number can you multiply by 6 to get 15? Nothing. What do you multiply the 1 by to get 3? 3. All right, so if it's equivalent, I have to multiply by 3 over 3. So 1 times 3 is 3, but 6 times 3, 18. So it does not equal it. 3/4 times what could give me 16/20? 4 times 5. Okay, so if the denominator is 4 times 5, that gives me 20. Is 3 times 5 16? 3 times 5 is 15. So those are not equal. 2/3 and 8/12. Well, what do I have to multiply thirds by to get 12 size parts? 4. I'd have to increase it 4 times as much. So 3 times 4 is 12. 2 times 4 is 8. 8/12 does equal 8/12. Okay, 8/10 and 4/5. Does 4/5 equal 8/10? Well, they have to multiply the fifths by 2 to get tenths. And I also have to multiply the numerator by 2. 4 times 2 is 8. 8 does equal 8, so yes. Okay, so that's it for equivalent fractions, our discussion of equivalent fractions. Our next session will be lesson 6.2, and its title is Generate Equivalent Fractions. So until then, may the numbers always be in your favor.